All right, it's at the store. $20 for parts only. What is it? It's HP goodness. It's not a real high-end DVM, but it's a DVM. So yeah, let me prop this up so we can photograph the front panel here. Oops. Okay, what is it? It's a Hewlett-Packard 3465A. I'll have to get the data sheet to see what kind of specs it's got. It only has a 1, 2, 3. It's a 4.5 digit DVM. That's not bad. It's got AC volts, DC volts, AC amps, DC amps, resistance, up to 20 megohms. It has a, let's see, 20 millivolt scale to a 2000 volt scale. That's pretty nice. Buttons feel reasonable. They don't feel bad to me. Sometimes these are super sticky. That seems okay. Power. Okay, so it says for parts. Oh, I'm not sure what that's going to mean. Either it works or it doesn't. You never know with these things. It's got a funny built-in, it's molded into the back panel is the AC connector. That's kind of weird. Standard. Let's see, I guess, oh, this is for the AC input, 48 hertz to 440 hertz on the, oh, here we go, here's some specs on the back. Let's see, DC volts, over voltage, 1000 volts, all ranges, resistance, let's see, amps, DC, AC bandwidth. Let's see, 1 megohm input. Oh, so it measures between 40 hertz and 20 kilohertz for AC. That's nice. I don't really see an accuracy spec on this thing. Yeah, somebody scratched off the calibration tag, I think. And it comes with its own power cord. Look at that. It's not an HP power cord, though. Somebody else's power cord, but that's okay. All right, let's get off our $20 label. That's probably worth $20 right there, right? I should put it on other things. All right. So once again, thanks to my viewers and patrons for giving me some money to spend on silly things. But I know people have been asking for me to do more repairs, so here you go. HP goodness. And we'll see how it works. And hopefully get a successful repair out of it. But you never know. Why is this not opening up? It's really stuck. These usually slide back. But this one is not. You can't watch me jab my finger. Huh. Wow. Oh, there we go. Ah, got it. All right. Plastic top. Oh, it has shielding inside, though. Let's see here. Let me move the camera a bit. So I would say it looks nicer on the inside than the outside. From the outside, it looks like a cheapy meter, but from the inside, it looks like a really, really well-constructed meter. Nice big ribbon cable to the front panel. Power supply in the back. Yeah, looks like there's shielding over some analog parts here, and then all the board's upside down, so all the parts are on the bottom. So let's take the bottom cover off too, hey? Or what's the front? Where's my screwdriver? Did I put it away? A Canadian way to say it, eh? I don't know if they really say that or not. Maybe they do. All right, that all comes off. Oh, very nice. Okay, let's get this out. Yeah, look at that. You see that? There we go. Yeah, it looks pretty nice inside. That trimmer cap here. That looks like it's on the. So when you look at these things, let me get a pointer here. When you look at these things, you're looking for things like this. This looks really, really interesting. There is a couple Teflon inserts, so we have super, super low leakage sections here. So that's always my vision goes straight to those things. I know this is kind of what the big thing, you know, the really important thing. This is probably a really low leakage JFET input op amp. Expensive capacitors. Look at this jobber here. And then trimmer things around it, right, to really tweak them. And these trimmer things are probably to tweak the AC voltage accuracy. Here is a custom IC that probably does everything. So if that IC is dead, there's no fixing this thing. I've only fixed one DVM in the past where I replaced a custom IC, and I had to build my own all out of JFETs and stuff. It was a pain in the butt. Look at that nice crystal over there. It's huge. It's a giant crystal. It's probably 100 kilohertz will be my guess. So, like I said, this area here was of great interest to me, but over here is a duplicate section. You can see a whole bunch of Teflon standoffs and a whole bunch of expensive components. A bunch of these TO92, these are probably JFETs. So this is probably the DC input to the section, and I'm guessing this is probably the AC measurement part of the meter. Let's see if we can get a date code somewhere. There's a -7. That doesn't really tell me much. Let's take a look at these ICs. 76, 77, 76, 76, 76, 76. Yeah, probably not far off. Probably late 70s, mid 70s. This is probably then 77, the custom chip. Everything is HP part number, so you don't know what anything is. MOSTEC. Very interesting. Very, very interesting. So, should we turn it on? Let's see what this jumper says here. This jumper says Compla CP. I don't know what that is. Do not touch, keep clean. Let's see if I can zoom in on that for you. Yeah, can you see that? Do not touch, keep clean. Actually, it says do not touch, clean handle. Okay. Yeah. Well, let's see what the power supply looks like. See if there's any nasty capacitors that probably are ready to blow up. And I only really see one. There is a, ooh, I just saw something interesting. We'll get to that in a second. But there is a yellow sprig cap down in there that might be ready to blow. But I saw something even more interesting. Even more interesting. All right, let's go way down here. Way down here, way down. You see that? That, my friends, it's a rechargeable battery. I think this thing runs off of batteries. I will need to learn how to open that door. But it looks like there's 3 AA's that look like Panasonic, really old Panasonics. The diamond logo. Yeah. Let's see. How does this open up? All right, I got the little door off, but I think I broke it. I broke a couple tabs off of it. Not that I really care, because I don't think I would repair the battery section of this thing. But it has, check it out. You're gonna love it. Look at this. HP35 calculator battery pack. And there's one that fits on this side, and there's one that fits on this side. And that other one is missing, but this one seems to be still around. Yeah, and this looks like it was a replacement. It does not look like original HP issue. It looks like somebody had replaced that sometime in the past. Let's see if there's any voltage on it, just for fun. Let's see if there's any voltage on it. Yeah, 0 volts. It's dead. But anyway, yeah, that's what an HP35, HP45, HP67 calculator. They had these metal hydride batteries, a little package like this one hasn't leaked all over itself, so a lot of people collect these and rebuild them. There's some goo in there, I can see. Anyway, yeah, so this thing had battery. You could use it on battery. Maybe we can just kind of like solder in another battery or something in there if we get it working. That might be interesting. But yeah, I don't know if you could see it, but on this side, I need to change the exposure here. On this side, there's also a little bail, a little metal bail, and the battery would go in here, and the bail would go over the top of it to hold it in. And then on this side, the door slides down, and that holds it in too, but I broke off a little tab on the door. But like I said, not that I care so much. It might be fun to make a little lithium replacement circuit for in there. I'm not sure if it's worth any effort on an instrument like this, but yeah, very, very nice. So I'll give you another tour here. Interesting piece of plastic in there too, and there's another shielding in here. Ooh, and look at that guy. He looks like a dual FET over here. Yeah, this is real old school. This is really nice. We're gonna have to get the schematics out, figure out how this thing works, and but I say, let's turn it on. I don't see any harm in turning it on. Maybe that capacitor is still good. Most likely. Okay, here it goes. Power on. Oh, look at that. Minus 0.11 blank 5. I'd say it's broke. I'd say it's broke. Or maybe that's the date code, huh? Maybe. It thinks it has a microprocessor. I didn't see a microprocessor in it. Let's, it says, oh, there's a number. Ohms? Number? Anybody? Bueller? Let's see here, let's get here's a resistor. Let's put a resistor in there. Yeah, nothing. Nope. 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 Wait a minute. Ooh, what is this? It's 500 ohms. Ooh, wait a minute. Did it almost work? Did it work once? It's 500. Oh, wait a minute. Why the switches funny? Let me put this in the here and put a resistor across the input. That way I can get my hands free. 400, oh, 500, no, nah, I think it's trying. Might be leak of capacitors, might be the power supply is just blah, 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 going up and down. We have 500. No, I think that's dumb luck. Yeah, oh, maybe that switches are dirty. 500? 5? No, 0.5. That one's 0.5, and this one's 0.5. And how about this one? No, I don't think it's working. I don't think it's working. Let's put some volts into it and see what happens. Let's see here, 200 volts. Let's go to 20 volts. DC, and here's 5 volts. Let's put 5 volts into it, shall we? Yeah, nothing's happening. Nothing's happening. So, all right. We'll need to embark on a repair video. Excellent.